everyone. Welcome, welcome. We're just going to wait a couple minutes to get started. It looks like some people are still connecting to audio. If you are able, please introduce yourself in the chat and let us know where in the world you are located. And also, now that we are deep into spring, what is your favorite season and why? Just so that we can get to know you a little bit in our community. If you're just joining us, if you can please introduce yourself in the chat, let us know where you're located in the world and what your favorite season is and why. For those of you who may not know me, my name is Shira Honig. I'm a member of TPG's volunteer-run Community Leads Committee, and today I am co-hosting this demo day with Marie Prado, who is a new member of our committee. So welcome, Marie. And also, not to put her on the spot, but Katie Johnson, who is also on video, is also another member of our committee. I am struggling with that word today for some reason, but welcome, Katie. Welcome, Marie. It's nice to see you. And so, yeah, for those of you who are new to TPG, just a quick background and some housekeeping before we get started. Technologists for the Public Good is a professional association. We empower and support public interest technologists by offering connections with other technologists across the US and even globally. Our common goal is to use our skills in the service of the public good and to help each other by sharing valuable lessons we've learned along the way. We hold regular events, we have an active Slack community, and we continually work to serve our members, and we also regularly welcome new members. And when you join, you're joining a community of more than 1,600 committed public interest technologists and growing from different backgrounds, so human-centered design, data science, policy analysts, and so on, who are all passionate about creating a government that works for the public. And if you're not already a TPG member, we'll put a link in the chat so that you can sign up with our Airtable if you're interested. We will put a link in the chat for membership. So Marie's just posted that, the link to the Airtable if you'd like to become a TPG member. And some other quick housekeeping notes before we get started and introduce our speaker today. We're going to be recording this session. In fact, it's already in progress. If you're interested in getting a copy of the slides, let us know and our presenter can send them to you. If you have questions during the presentation, please write them in the chat and we'll keep track of them and we'll do our best to get to as many as we can. We may, we could pause the presentation for questions if that's a preference, or we can wait until the end, whatever works. But if you're champing at the bit to get your question, recommend that you use the chat. And if we have time, we can also do some live questions toward the end. And finally, we are going to run a couple of very quick polls today. We're going to run a quick poll, I think now. Does now sound like a good time, Marie? We can get that poll started, and we'll just give folks a couple of minutes to answer a couple of very quick questions. Okay. So if that's done for most people, all right, so we're going to get started. So we are excited today to have Andrew Trask, who's the founder and executive director of OpenMined. Andrew started OpenMined 6 years ago on a mission to create an accessible ecosystem of privacy tools in education. His passion for research and education has led him to teach multiple online courses in AI and privacy, author a deep learning textbook, and become a senior research scientist on the ethics team at Google DeepMind. He's now completing a PhD in AI and privacy at the University of Oxford. For those of you who are not joining us from OpenMined, OpenMined is a not-for-profit organization of more than 16,000 cryptography researchers, engineers, and educators who are building and deploying open source infrastructure for facilitating transparency of AI systems. Andrew and his team are on a mission to build an accessible ecosystem of privacy tools to help AI researchers understand the impact of AI on society. OpenMined has a long history of facilitating access to non-public, protected, or otherwise sensitive data, often leveraging privacy-enhancing technologies or PETs. Today, Andrew will be presenting on how OpenMined facilitates such access at a high level, and then he'll walk us through a live demo. He'll describe the implications of a world in which access to data is not blocked by privacy, security, legal, or other valid reasons that many of us in government are very familiar with, as well as the use cases that OpenMined is exploring. So welcome, Andrew. Over to you.
Thank you. Really excited to be here, and thanks for taking the time. So I'll start by sharing my screen. You can double check that we're on the right path. Let's see here. How's that look like?
Perfect.
Excellent. Then we'll jump straight in. Thank you everyone for coming here today and for your time and attention. So today I'm going to be talking about new ways to facilitate access to non-public information. I'm going to try to make this a little bit tech focused, but also very practical focused in terms of really try to get into the nitty gritty of how we can overcome some of the traditional long-standing barriers to non-public information. So I think this is a really beautiful union between our two projects, so with Technologists for the Public Good and OpenMined, and I hope that you see sort of the synergies between the things that we can unlock together. So first, I want to talk about a little bit of the history of the open data movement in government, as I understand it. So, and open data authorities. So as far back as 2009, we already started to see some policy statements around sort of calling for governments to make their data open. A great quotation from around then from the Chief Innovation Officer in the United States, that there is a lot of data the federal government has, and to make sure that all the data that is not, that we need to make sure that all the data that is not private or restricted for national security reasons can be made public, right? And on the heels of this sort of general sentiment that was expressed by senior policymakers, that's what happened. Here we go. Can you guys still see that? I hit like a key. Interesting. I'm gonna re-screen share real quick. So on the back of that, there's a variety of different tools and open source technologies that have helped to come facilitate this. So I'm going to re-share the slideshow and then not just mash my keyboard while I'm talking. So there you go. Here we go. So for example, we have data.gov, which many of you will be familiar with, that has made a lot of data sets available from the US government. This launched, gosh, has it? Man, a while back now. It's been around for a little while. Later in 2012, we started to see some laws come into place. So for example, here in New York, you can see the council hereby finds and declares that it is the best interest of New York City that its agencies and departments make their data available online using open standards. And then we can see this through the portals that then follow along with the guidance of this law. Man, each time I click, it's closing for some reason, but I'll do this one more time, and then I'll stick to the space bar instead of doing clicks. And then there's a variety of other portals, which I'll click through a couple of them real quickly. And you can see types of things that are a part of this movement. Here we go. So, for example, in the Utah State Legislature, we see, this bill provides provisions related to the availability of public information and the duties of the Utah Transparency Advisory Board, and this translated into projects like the Open Data Catalog in Utah. Following up in 2019, we see bills like the Foundations for Evidence-Based Policymaking Act. We see the Open Government Data Act, and we see new strategies like the Federal Data Strategy and the statistics they provide around what types of data sets are being released to the public. And even as recently as this year, we see this desire for openness continuing to be held by the government, as most recently as the open call from the National Telecommunications and Information Administration, asking about whether new policies and new standards should be around making AI models and specifically their weights open or closed source. And so just to recap, many jurisdictions in the US have at a minimum policies and in many cases laws that are encouraging the release of open data. And the open data movement aims to make government more open and accountable. It can increase participation in government, create opportunities for economic development, and inform decision-making both in the private and public sectors. However, right, we're hitting a limit. Not all data can be made open, right? As many people on this call will be familiar, there are legitimate privacy, security, intellectual property, national security, logistics, costs, lots of different challenges that can prevent data that would otherwise be very valuable to society from being made open, right? And as a result, much of this data is staying closed. And the thesis that we're going to explore in this talk over the next few minutes, and then we can talk about some in the Q&A section, is the degree to which a new class of technology called privacy-enhancing technologies can mitigate the barriers that are preventing data from being made open and sort of return back to this mission to make the rest of government data available for use by people in society. Right? So, what are PETs? Let's go back to the beginning. The PET stands for Privacy Enhancing Technologies, and loosely you can view it as a bunch of different people, a bunch of different academics in a bunch of different academic departments at some point looked down and went, I feel like this tool could be used to help preserve privacy, right? And they started working on it independently. And what the PETs term refers to is this kind of loose umbrella of disconnected fields that had a similar mission kind of by accident. If that makes sense. I mean, they had some values in common. So when you hear about PETs, expect it to the history of PETs to be a little bit disorganized because it's actually a collision between a bunch of different fields that are still trying to figure each other out, if that makes sense, right? But we can already start to see a couple groups, right? So we have some PETs that fall into a category called input privacy technologies and some PETs that fall into a category called output privacy techniques. And more recently proposed two other clusters of privacy enhanced technologies, input verification and output verification. We don't have to get into what those are just yet, because what I would actually like to do is zoom out for a minute. Instead of focusing on these specific individual technologies that are in the midst of colliding, try to say, okay, wait, when all these things actually come together, what's going to happen? Right? And what's going to happen is it's going to make it possible for someone who is outside of an organization, like you and me, being outside of the government. Well, some of you might work for the government, excuse me. Outside of many agencies in the government, you don't work for every agency in the government. So, being able to access and answer a question using data that is inside of an organization that you're not a member of, if that makes sense. So answer question using data that you cannot see, meaning the data is inside of an organization and you can extract the answer to a specific question without seeing the data, right? And so what I'd like to paint for you, if you've already heard the term PETs, I would really like to paint for you this new way of thinking about it, where instead of focusing on PETs as a collection of individual algorithms, each of which have their own pros and cons and all this kind of stuff, and more as an emergent capability that is likely going to use an ensemble of these things. Let me describe a little bit more. So like the PETs in practice is going to look like this. You got a data scientist, you got an organization with data, and a data scientist will be able to extract the answer to a specific question without getting a copy of the data, right? So they can remotely study that data at another organization. So individual privacy enhanced technologies often fail. I want to be very, very candid. So if you've heard about privacy enhanced technologies before, you might have heard of specific technologies like federated learning or differential privacy, secure enclaves or homomorphic encryption or secure multi-party computation, et cetera. What I'd like to make the case to you is these are like individual pieces of a puzzle, right? And just using each of them by themselves has a very, very limited sort of area of influence or area of utility. And there's a significant percentage of the PETs industry, because they're approaching the PETs field with expertise in one particular area, that it's sort of like federated learning is all you need, or secure enclaves is all you need, or homomorphic encryption is all you need. And that can create a sort of a bit of a misnomer in PETs in terms of their effectiveness overall, right? My argument here is that PETs actually have to be combined to realize their full potential. And so just to use an analogy, it's sort of like everyone in the PETs industry is sort of working on individual car parts, but we don't yet have a car, right? We don't yet have this general purpose, easy to use piece of infrastructure that has a bunch of technology buried underneath it, but that an everyday person can sit down and go somewhere with, right? Or to use the PETs analogy, an everyday data scientist or statistician can just do their normal stats and data science thing, but the data happens to be over there, right? That's the piece of infrastructure we don't have, that PETs are kind of like low-level parts that are supposed to be kind of building up towards. Right? And because we don't have a car, it's very difficult to envision what a world with cars looks like, or what a world with robust PETs infrastructure looks like, because it looks like tremendously available non-public information, right? So all the data that exists in all the different places in the world, in theory, we can have access to, right? But it's hard to envision that unless you sort of think about what the infrastructure will look like. So in today's talk, what we're going to try to do is imagine what the world will look like with privacy-enhanced technologies that are fully mature, and what it means for us to minimize misuse of information while maximizing innovation and maximizing all the good things that access to data can facilitate. So what is this car of PETs? When all these different ingredients finally come together and create the thing, the general purpose vehicle for data science and statistics, what is it going to look like? What I'd like to argue is that it looks like a web server, right? it looks like an Apache web server, but for private information. So if the way that the Apache web server or the web servers today work is they hold a bunch of files, right? And you click a link and it downloads those files into your browser and your browser shows them to you. This is a new type of web server that is different in a key way, right? So let's walk through the basic flow. An organization has some data. They launch one of these servers on a computer that they control. An employee of that organization loads some data into their server, creates an account for external data scientists and statisticians, and then goes and has a coffee, right? And in theory, then this external party can remotely, using data science and statistics tools, log into this server. They can download answers to specific questions that are allowed, meaning they can download answers to some questions, but not other questions. Like they can download the answer to what causes cancer, but does a specific person have cancer? Nope, can't answer that question, right? This sort of difference between allowed questions and not allowed questions, right? And that's the privacy enhancing technologies part, right? The ability for this data to live in this server and someone to extract just the specific answers to some questions, but not others in a highly automated way, right? Where the data owner, the administrator is still off somewhere else, sipping coffee, not paying attention, doing whatever, right? So notice what's missing from this vision. Data partnerships, meeting with lawyers, getting on the phone, background checks, all the stuff that accessing private data actually requires right now. So if you want to talk about what are pets actually for, this is going to sound kind of boring, but it's kind of brilliant. What they're actually for is about automating all that legal stuff, right? They're about reducing legal barriers, reducing the need to do bespoke partnerships, reducing the need to do phone calls, all this kind of stuff. That's what the actual output should be, right? The bottom line is that answering questions using another organization's data will be as easy as going to that organization's public website. That's the point, right? If we get to a point where pets are fully integrated and fully mature, and they know how to enforce data use policies, they know how to enforce the difference between questions that are okay and questions that are not okay, this is the outcome that we get, right? And that's a really, really, really big deal. Okay, so I want to talk to you about an early project where we're trying to, with open source public infrastructure, build a car for pets. This software library is called SIFT or PySIFT. It's freely available online. You can go check it out. And we're going to walk through a handful of different pet ingredients that come together inside of PySIFT to help make this possible. So the first ingredient we're going to talk about is remote execution. Remote execution is kind of like the heavy lifting of privacy enhanced technology. All it basically is the data stays over there and I can remotely do my data science from a distance, right? So that's the first thing is don't download a copy and send your code into wherever the data happens to be. So the first thing that PySIFT introduced as a new core primitive is a notion of a worker or a server, right? So if every statistical package you've ever used before is based around the idea of a tensor or an array or a matrix or a spreadsheet, a list of numbers, right? Whether it's Excel or MATLAB or PyTorch or JAX or NumPy or whatever, the core data structure is this list of numbers. The first new primitive, the new statistical tool that we think will be universal across all these statistical tools is the notion of a worker, right? And so in the future, whenever you're doing statistics or data science or machine learning, AI research, there's going to be two core primitives that all software packages have. The tensor, that is like the list of numbers, that kind of core data structure, and the worker, where that tensor lives that you're doing stuff with. So in this case, let's say we have a variable here. It's pointing to an actual computer sitting in an actual hospital somewhere. And I can take my tensor, 1, 3, 4, 5, and I can send it into the hospital. Now, what gets returned to me? What gets returned to me is a pointer variable that has exactly the same API as if I had the tensor locally, if that makes sense. What that means is I can kind of pretend that I have the data locally and do data science as if I have a local copy, y equals x plus x, right? But when I actually do that, it's sending a message into the hospital, it's finding x, it's adding it with the other x, and then I get a pointer to the result. Right? So again, I have not learned anything in the process yet, but I am doing data science, and I'm doing computations on this remote machine. And if I want to see the result, I use this very special method called .get that can download this result down to me. And we're going to come back to that because that's obviously a really, really important bottleneck. So that's tool number one, right? Tool number two, basic stuff like search and example data, right? So this gets into the question of like, how can I possibly do data science when I'm not allowed to actually look at the data by default, right? And the good news here is that a lot of the tools, so a few things. One, there's public metadata that you can use, right? So a lot of the search is like, okay, where are their cancer data? Where is their, census data? Where is their demographic data? Where is their, et cetera, et cetera. So some of the metadata can be made public for you to go look for. And then after you have it, you can take a look at, data set descriptions, how it's collected, these types of things can be made public. And then of course, a fake or sample version of the actual data, right? Do not underestimate the power of a fake or unexpected version of the data, because this is what allows you to say, okay, it has this many rows, this many columns, this is what the data type is. And I can write my code against a fake or mock version of the information with high confidence that it's going to compile and run and answer a specific type of question that I'm looking to answer, right? I want to calculate the mean of this thing or standard deviation or do linear regression, whatever the case might be. And so then when I send my computation into the hospital, I know what I'm computing over there, right? With a pretty high degree of fidelity, right? At a high level, the reason you can do data science on data that you can't see is for two reasons. One, a lot of the tools that you use when the data is too big for you to read everything transfers over very nicely to when the data is just too private for you to read everything, right? So this is sort of big data tools transfer over and the big data user experience transfer over really nicely. And two, rigorous data science and AI and statistics often involves not p-hacking, which is supposed to involve not looking at the data for, not looking at your test set or not looking at your data too much or too closely, right? The third reason that it works out is that technically you can still ask the data owner to see anything that you want, but you might have to wait, if that makes sense, for some type of review if their automated infrastructure can't support it. So I stand by the statement that any type of data science you can do when you have a copy, you can do when you don't have a copy, because of the way this infrastructure can work. Okay, now let's talk about a third tool. And this tool is called Differential Privacy. I think there's actually another way to do, yeah, let's do this. So differential privacy, oh no, I'm getting squished. We'll fix that later. So differential privacy is a really powerful tool that makes it possible to ensure that statistical analysis doesn't compromise privacy according to a certain definition of privacy. So imagine that you have this database on the left-hand side, and you have a bunch of people, and they each have a 1 and 0 next to their name. And that 1 and 0 corresponds to true, false for something like a disease, if that makes sense. So a 1 would mean maybe they have COVID, or a 0, they don't have COVID, something like this, right? The idea of differential privacy says that if I query this database, and then I remove someone or replace someone in the database, and the output and then query it again, and these two queries are exactly the same, then I have perfect privacy for that person, if that makes sense. So like if I have this database and I query it and I get a 10, right? And then I remove someone from this database and I query it again, if the answer is still 10, then whoever I removed, their information is not being leaked through the query. Does that make sense? Because whether they're in the database or out of the database, it doesn't matter. I'm getting the same answer, right? So clearly their information is not coming out in this query. That's the intuitive definition of what perfect privacy means in the context of differential privacy. Now, obviously, there aren't that many queries that are independent of the data, right? If that makes sense, or independent of small perturbations of the data. And so this brings us to the type of mechanism that comes into play when people are using differential privacy as a definition. And what people do in practice is they will add noise somewhere in the computation to try to make it so that it's very difficult to tell when someone has been removed or replaced in the data, so that you can sort of adhere to this type of definition. Let me give you an example of what I mean. So I have a twin sister. She is a social scientist. And in the social sciences, sometimes they need to survey a group of people with a question that is very taboo, right? So for example, I might want to ask everyone in this room, whether you broke the law in a particular way in the last 10 years, whether you jaywalked or, did an illicit drug or, whatever, right? And I am a social scientist. I'm not law enforcement. I'm not trying to arrest you. I'm trying to understand a phenomenon. So what I'm hoping for is that for people will be honest with me so that I can do accurate results. And what there's a technique called randomized response, which social scientists will use, where I, if I were to do this with you, I would sit down with you and I would say, okay, here's a coin. Somewhere that I can't see, I would like for you to flip this coin twice, right? And I'm asking you, did you break the law in the last 10 years? And if the first coin flip is a heads, I want you to answer honestly. Did you break the law or not? But if the first coin flip is a tails, I want you to answer true or false according to the second coin flip. Okay. Now, what that means is that roughly half of you would be honest with me, and roughly half of you would answer 50-50 according to a perfect coin flip. But I don't know which answer is in which half, if that makes sense. So each one of you has plausible deniability. If you tell me, oh, yes, I broke the law, it might have been because you actually broke the law. Or it might have been because you just had a certain series of coin flips that told you to tell me that you broke the law. However, when we take a step back for a moment and consider the data set as a whole and consider my query of like, okay, how many people broke the law? If the result from my query is 55%, let's say 55% of people said yes, they jaywalked or did some other, crime. Or maybe this whole talk is populated by people who are murderers, and I should be very careful. I'm grateful that we're on Zoom. If 55% of you said yes, then I would know, or I believe, that the true statistic is 60%, right? Because 60% got averaged with a 50-50 coin flip, and the average was 55. And that's the result that I got out. Taking a step back, what that means is I'm able to recover the statistic that I'm interested in, on average, how many people were committing a crime, even though I don't know which one of you actually committed a crime, right? And this intuitive notion, the degree to which you have plausible deniability, it comes down to the bias of the coin flip. So if the first coin flip is having everyone be honest, then you have less protection in a weird way, right? Because I know that 90% or 95% of people were answering honestly. So if you told me you committed a crime, I know it's very likely you actually committed a crime. But if the first coin flip is more and more likely to be a tails, where more and more likely for you to be lying to me according to the second coin flip, then I know you have lots of plausible deniability. Because if you tell me, oh, yes, I committed a crime, I'm guilty, I'll go, yeah, it's probably just because of the coin flips, because most of the people are answering according to the coin flip, right? So you can adjust this based on how much protection you want to give to someone. And so coming back to our definition of differential privacy, this is a really, really powerful concept, right? Because it means that if I have some query that's querying a database, right? And I'm worried that, oh no, if I remove someone from this database, it really changes the output of the query, right? That I'm learning potentially a lot about individual people when I'm creating this database over and over and over again, right? That adding noise to the query process, either to the raw data or to the output before I receive it, this kind of stuff, creates the same kind of plausible deniability, right? Let me give you an example. If I queried this database for a sum, like I wanted to add up all these numbers, and then I removed Bob and queried it again, I got the sum, the difference would be off by 1, and I would know that Bob's answer was a 1, right? Because I could tell the difference between those two queries. However, if there's noise in the system, then it might have been because Bob was removed, or it might have been just because I'm seeing the noise, if that makes sense. Because every query is non-deterministic and is getting perturbed each time I do it. So what does this mean for pets infrastructure? Why did we go on this big, long rabbit trail to explain differential privacy? Well, a moment ago, I was talking about this scenario where I had remote access to a data set somewhere, right? In this case, let's say it's a data set about diabetes. So I've got a pointer to a data set sitting in a hospital somewhere, right? Now, let's say I try to download this data set, right? Whoa. You can't download this private data. This is owned by the hospital, right? You can only query private data if noise is added, right? So use a special query to be able to add the appropriate amount of noise. So instead, I pass in something called epsilon. And epsilon is configuring how much noise I'm adding to this data before I download it, right? Now, the interesting thing here is then when I get these values, I might not know whether any of these values are true, right? Because I know all of them are noised up in some way, but I can do statistics based on the output of them and still obtain aggregate results. For example, let's say this, just like we did when we were querying how many people had committed a crime, if that makes sense. Now, you might say, oh, Andrew, what is this? Like, I'm just downloading a noisy version of the data. Isn't that making my results less accurate, right? Well, there are more sophisticated versions of this tool that allow you to do something that's really quite clever. And what that is instead of doing this and downloading it directly, right? The implication here is that I could actually do some remote data science on this data set, right? And calculate whatever my result I want be, the standard deviation or linear regression or whatever the case might be, right? In a way that hasn't added any noise yet because I'm doing it remotely. And then when the time comes to download my final result, to ask for the final result, I can say, I would like this final result within this many standard deviations of the true value, if that makes sense. So let's say I'm trying to calculate the average age of the state of Minnesota, right? And I query a remote data set for the average age of the state of Minnesota. And I say, I would like to know the average age of the state of Minnesota where within with a 95% confidence interval that I'm within 2 years, if that makes sense, right? And here's the really crucial part. Normally, that type of query would require someone, in a government agency in the state of Minnesota, whoever's holding this data, to manually inspect the code, right? To manually review everything that's going on, right? And the way this would happen is usually traveled to a physical building and you did your code project and then they reviewed the whole thing. And that is a very time-consuming program to run. However, with this type of tool, someone in the government of Minnesota can set what's called a privacy budget. And what a privacy budget can do in this type of context can say, okay, when you're querying certain types of data for certain, even down to certain columns of certain data sets like age or something like that, we want to make sure that people can't reverse engineer more than a specific accuracy for this dimension, right? Meaning, if I did a bunch of different linear regressions, if I did a bunch of different independent SQL queries, if I did a bunch of different, statistics and deep learning and all this kind of stuff, that I took all that together and tried to reverse engineer the age of a specific person in Minnesota, that I would never be able to get within a 95 confidence interval of 2 years, right? And what that means is that when this infrastructure is fully mature, and it's not, it's a lot of it's still coming, someone in the government in the state of Minnesota will be able to say, this is our risk tolerance for this particular parameter. People need to have this detail about themselves protected to a certain degree of fuzziness, if that makes sense. And they could configure that into a system and they could walk away and the system would know how to enforce it. Where I could do remote data science and download my results automatically without having to wait. And that's a really, really big deal because it means that instead of traveling to a physical location, right? Instead of doing my data science project and then sending my code over to an analyst, and the analyst reads the code and then consults the legal policy and right? It works like the internet. It is as easy and as fast as querying someone's public website. That's the vision, right? And that's why differential privacy is useful. It is not useful. I mean, to some extent it's useful because it is a more rigorous, it can be viewed as a more rigorous privacy protection, but I can point to challenges with that argument as well. The real reason differential privacy is useful is that it is an analogous tool to what people are doing manually, right? That can provide a high degree of automation and cost cutting. And it turns out that's a really big deal. Because if you look at why the internet was a really big deal, the internet wasn't a big deal because it created access to information that didn't exist before. It created access to information that you didn't have to get on the phone to go get, right? Do you see that difference? Like the information that became on the internet in the 90s and 2000s was the same information you could have gotten on the phone. You could have ordered plane tickets and, call a librarian to ask about a book, call a bookstore, call a business, all this kind of stuff, right? But they could only operate so many telephone lines, right, to actually answer your call. The reason the internet's a big deal is because individual organizations can then serve information to millions of people, right, without having to have huge staff. Pets are the same thing for non-public information. Okay, we're going to keep going. So differential privacy is great. We talked about this. I want to talk about one more tool before we get into a more practical demonstration, and we'll have time for Q&A. Secure multi-party computation. Secure multi-party computation is the coolest algorithm I've ever seen in my whole life. I think it's cooler than deep learning and AI personally. It's just crazy, crazy, crazy cool stuff. We're going to go through a really simple algorithm and you'll get an essence of why it's so cool. The textbook definition of secure MPC, secure multi-party computation, secure MPC, SMPC, these are all referred to the same thing. Multiple people can combine their private inputs to compute a function without revealing their inputs to each other. This is a bit of a messy definition. It's technically true, but like hard to wrap your head around. The implication is much simpler. Multiple people can share ownership of a number. Share ownership of a number. Okay, this is super, super wild, but bear with me. So let's say I have the number 5. Cool, I've got a number 5, great. I'm going to split that number 5 into 2 shares, a 2 and a 3. Okay, and I've got 2 friends, and I'm going to give these 2 shares to my 2 friends. So 2 plus 3 equals 5. That's our fancy encryption algorithm. Okay. Now I give these 2 shares to Marianne and Bobby, and then I disappear. Now, the way that they would decrypt this number is they would add their shares together. But here's the thing. Marianne only knows Marianne's share, and Bobby only knows Bobby's share. And the other person's share could be positive infinity or negative infinity. They have no idea what the other person's share might be. And so what that means is that each person has no information about what number might be encrypted between them. All right? However, the unique aspect of this type of encryption is that they get shared governance. This number can only be decrypted and used if all of the shareholders agree. If you're missing even one shareholder, right, no one can use the number. But here's the even more incredible aspect of this. While the number is in its encrypted state, while it's in this shared governance state, you can do computation. It's pretty wild. Let's check it out. So let's say Marianne and Bobby wanted to multiply this hidden unknown number that they don't know what it is by 2. Just like multiply it by 2. Well, if Marianne takes her share and multiplies it times 2, and Bobby takes his share and multiplies it times 2, all of a sudden, now they have an encrypted 10, even though they don't know what it is, right? And it's still under the same shared governance paradigm that the input was, right? So now, here's the real kicker. It's not just that you can share ownership over individual numbers. Statistical models and data sets are just large collections of numbers, which we can individually encrypt. Want shared governance over an AI model? Want shared governance over a statistical model? Want shared governance over a data set? Take each number, split it into shares, give them to shareholders. Cool. Let's see this in practice. This is a library called PySIF that I mentioned a moment ago. We're going to see these different ingredients that I just described put together in a prototype that was deployed across 2 test servers in the United States and in Canada on a network hosted by the United Nations Statistics Division. First things first, let's look for some data networks. This is like DNS or search, but for non-public information, okay? Oh, look, the United Nations Pet Lab. Let's see if they have some data. Looks like there's a few different servers here. Okay, this is still the early internet. We're very small number of servers, right? There's one here in the United States and there's one in Canada. Cool. Let's look closer. Let's log into each of those servers and see what kind of data sets they have. Well, first, we'll check out the privacy budget. Cool. We've got a bunch of privacy budget. Lots of querying we can do in a moment. The data set in Canada. Trade flows with the United States of America of the following type: dairy produce, birds, eggs, natural honey, edible products of animal origin, not elsewhere specified or included. Okay, so we've got some trade information on Canada importing and exporting with the United States. Pretty cool, right? So this is in Canada records of how much dairy produce they think they're importing, exporting with the US. Let's check out the US data set. Oh, cool. Trade flows with Canada of the following type: dairy produce, but this is in the United States. So this is how much the US thinks it's exporting to Canada of this particular type, right? Sitting in 2 different servers in 2 different countries hosted on a network by the UN. Cool. So what happens next? I've got these 2 pointers, right? One variable is pointing to a server in the US, and the other one is pointing to a server in Canada, right? For the same type of food, right? In theory, these numbers should match. Why? Because in theory, the amount of dairy that the US exports to Canada should be the same as the amount of dairy that Canada imports from the US. In theory, you might see where I'm starting to go with this. Okay, this cell should be impossible. Why should this cell be impossible? Because I'm subtracting two numbers that are in different countries on different computers. Does that make sense? It should not be possible to do this. Using any other type of technology, it would be impossible to do this. But here's how we did it. When we did this behind the scenes, it instigated a shared governance paradigm, right? It took the variable in the US and split it into two shares and sent one of those shares to Canada. Canada didn't learn anything when they did that because it's just a random number for the reasons that we just said a minute ago. And Canada took their number and split it into two shares and sent one of them to the US. The US didn't learn anything in that process because it's just a random number, right? Because it's a key, right? But now, because both of these variables have the same shareholders, we can do computation together. We've got compatible governance regimes because any results of this computation are also going to be shared by US and Canada, meaning they still have veto power over whether anyone gets to learn anything, right? But while they're deciding whether to exercise that veto power, they can watch the computation and see what people are doing. Does that make sense? Okay. Now we're going to get into the differential privacy regime. I want to download this result, and I want to do it automatically. So what I'm going to do is I'm going to say, okay, here are the standard deviation that I want to be able to download this to. So I think it's 20 or 200,000, right? Which is pretty big. So I don't need to know whether these are exactly the same. I want to know whether these are roughly the same numbers, whether the US and Canada have roughly accounted for the same amount of dairy produce crossing their border. And it turns out they haven't. There's a this estimate says that there's a $1.65 million discrepancy between how much produce the US thinks it's exporting to Canada and how much Canada thinks it's receiving, right? And then we spent our privacy budget, which is why we were able to download this result automatically, right? No waiting, no traveling to physical locations, all this kind of stuff. There is so much about the computation that I just showed you that is either impossible or impractical in the current regime. Why? It's impossible because trade records for Canada are in Canada. They're not in the United States, right? High-level statistics like the ones I just showed you. Okay, yes, they do make those public, right? But imagine this is actual private data sitting in Canada, right? That has not been released, right? It cannot be joined with data in another country, in another server, right? That is blocked. There are whole categories of statistical calculation that are impossible to do because data can't leave the server or the country or nationality that it sits in, right? And this is a means to get around that. Second, that differential privacy, that .publish that was just there, over is whole buildings that organizations don't have to buy, right? Normally, if you want to run an external researcher program with super secure data, you have a physical building with physical computers that people physically travel to go and study your data. And you have to hire physical analysts to sit there and read people's code and decide whether to release it. That algorithm I just showed you means governments don't have to buy buildings. That's a big deal, right? That's the difference between having 10 people study super private data and having 10,000 people study private data, right? That's why pets are a big deal. It's by analogy, it's like libraries are to the internet what today's private access infrastructure is to this stuff, if that makes sense. It's the difference between having to go to a physical reference library or call someone on the phone versus going to a website in terms of how it's handled. Now, thank you. That was what I wanted to tell you. I hope you found that interesting. Let's talk about it.
Thanks so much, Andrew. That I was literally looking at the clock and excited that that we have some time for some Q&A. So thank you so much for that presentation. We have a question in the chat from Anicia. Do pets potentially worsen the problem of using biased data sets and models to make decisions? Who is responsible for identifying / understanding and conveying bias in the data set that may further marginalize populations who are typically excluded or not well represented in data? That's a great question.
Phenomenal question. There's two ways to look at this question. One is the responsibility of each individual person for triaging the degree to which their data set is biased, right? And two, what the overall data ecosystem looks like that leads to greater or less degrees of representation, right? So in the first instance, I would argue to you that any analysis that, that you can do when you can see the data, you can do when you can't see the data. In the worst case, if you can't use the differential privacy mechanism, it has to go for manual review, but you can still do it remotely, and you can still do joins across multiple organizations. So there's still a step up in terms of your ability to access data, without necessarily a step down in your ability to actually see what you need to see to study important properties like that. That's statement number one. That's like a relatively weak statement, because all I'm saying is like, I don't think it will really get worse than it is now. Here's the bigger statement. Representation in data comes down to what data you have access to. People do not have access to enough data now. This technology is going to lead to 1,000 times more data in every scientific field and industry. And that is going to radically increase representation availability practically for your practical data scientist and researcher in an everyday basis relative to what they have now. So I have extremely high expectations for the ability for this technology to increase representation in statistical studies, because instead of just doing a health study on the data in the hospital I work for in one part of the country that only works with one particular demographic, I can use the data across all the hospitals in the US by some network hosted by the NIH, if that makes sense. That's the difference. And so I think that my personal opinion is that this technology will lead to a landslide increase in quality and representation in all statistical studies across all subject areas, just because of it's a radical increase in availability. But that's my opinion.
Andrew, just as a follow-up to that, could it be an issue? What happens if there is a community or group or subset of folks who are excluded from a particular data set? Does it necessarily change that? Because you're talking about data sets in a broader perspective, but what about one particular data set where, you know, there is exclusion within it?
That's a great question. So this comes down less to pets and more to a question of governance. In the literature, and actually this is true of privacy regardless of pets. So set aside pets for a second, right? Privacy has a privacy utility trade-off, right? The more you reveal about a certain, say, underprivileged or threatened group, the more you're going to know about them, if that makes sense. And so in a perfect world, we would have the ability to facilitate every possible use and prevent every possible misuse of information in society, right? What pets allow you to do is have a finer grained control over that question. But then there's the second question of like, who do you actually put in power to make those calls? If that makes sense. So for example, my mom's side of the family is from Oklahoma. Oklahoma is heavily Native American population. This population is currently, actually I don't know the state of the actual complaint, but there is a complaint in the use of differential privacy in the US Census Bureau because it obfuscates some of the representation of smaller groups so that it might protect them, if that makes sense. When I was referring to earlier that sort of there is no such thing as a single privacy-enhancing technology that solves all the problems, this is the type of thing that I'm talking about. So I'm not a big fan of synthetic data and one-size-fits-all privacy budgets, where I say, I have a data set. There are some Native American populations in it. I don't know what's going to happen to them if I release this data set. So I'm going to have a really conservative differential privacy applied to the whole data set. I'm going to release that synthetic data set into the wild, and I'm just going to hope that good stuff happens and not that bad stuff happens, right? This is not how the fully mature version of this technology is going to be, right? The fully mature version of the technology is going to be each individual Native American tribe is holding a server that has data about them in it, and they have the ability to tune how much they want to be represented in specific queries and specific projects. That's the future, right? The future is, I want to be crazy represented when, you know, some government agency comes by saying like, hey, do you need more money for your population because of things that are happening that the government needs to help alleviate, right? And I'm going to fuzz myself a lot more when someone comes by who I suspect might be trying to hunt down people who have had an abortion because I need to protect that part of my population, if that makes sense. And like, this will be calibrated on a use case by use case basis. And the literature to the contrary is based on a relatively unbaked and adolescent perspective of what pets are actually going to be in the end, if that makes sense. So that's my argument anyways.
No, thank you. That sounds like it would be something like diverse, diffuse ownership, which is kind of what you were talking. Yeah.
This is why when you zoom out, it's going to shift a lot of power towards people who either created, who basically who are the original creators of the data set. Pets are very much, they cut out the middleman, if that makes sense. Like they naturally move ownership of data closer and closer to the source. Because from a market or even ethical or policy perspective, like today, if I want to bring my data to market and have people do stuff with it, I have to give people copies, right? That's a huge problem, right? It's a huge problem economically because it means I'm giving away revenue to like every customer becomes a competitor for the future sale and use of my data. And from an ethics or policy perspective, every time I give a copy to someone else, I am giving them governing power over what my data gets to be used for. Period. Like, yes, I get that there's laws, I get there's like stuff that tries to catch it, but it's really, really, really hard to enforce. But if underprivileged populations or local civic organizations that exist to serve them are the ones actually stewarding the data about them, they can make much more fine-grained control decisions about when they want to be hugely represented and when they don't want to be represented. And the purpose of differential privacy is not to fuzz them in every single possible data science project, is to scale their desires so that tens of thousands of people can do lots of projects and they don't have to hire a huge team of people to manually review every single code project. They just have to say, oh, they're value aligned with us. They're deciding, what our welfare checks are going to be or what our Medicaid policy is going to be. I'm going to turn down differential privacy for them because I know they want to be accurate in these different areas. Oh, they're a random researcher from an organization that published some papers that look like they might be trying to like discriminate against us. I'm going to crank this way up on the off chance that like I can't trust them, if that makes sense. That's how the system will work, which is categorically different than how pets have been used in like the kind of larval early adolescent stage that we've been in for the last few decades.
Thanks. That's a really helpful answer. It sort of relates to some of the questions that I had for you, which are, the application to government, what recommendations you might have to for government. Does the government need to do certain work in order, because you're talking about remote execution from the external side. What about internally in government, what the work that they need to do? And I could tell you quite frankly that there are some government agencies that are very reluctant to give that power to those communities, right? It can become a bit of a power struggle, if you will. Sure. And so that sounds like more of a question for governance as opposed to pets, right? That the governance piece is the tougher one, is the one where government agencies have to accept that these communities have the right and the need to own their own data. But I'm wondering if you could speak to a little bit more about recommendations you may have for government aside from that, and what kind of work, because you're talking about APIs. In some cases, APIs may be very immature in some government agencies and so on. So wondering if you could speak to a little bit about what government may need to do in terms of APIs, in terms of digital literacy, in terms of data literacy, or other things that may be applicable.
Yeah, I cannot, education and pilots have the potential to be hugely more influential in this space than you can possibly imagine. If the internet evolved in a different way than mobile technologies, and it did so for one reason. For the early days of the internet, the government stepped in and set the tone for the whole piece of infrastructure. That was through funding, that was through government agency participation. It became a network with a global network effect that has certain culture and certain values that carried forward. Mobile technologies went exactly the opposite way. It was totally flooded by big private enterprise, and it is now dominated by two parties in a very sort of dramatic fashion, right? Just be present. Do early pilots, do early education, be loud. The more is better. The earlier and the louder that this new network, and it is a new network, it's totally new, right? Nothing like this exists right now. The tone with which this and the culture with which this new network starts will come from whoever is there first, whoever is the seeding body, the seeding groups, the seeding government organizations that happen to be there in the very, very early days. So just be passionate. Just lean in and say, I want the future of the government's non-public data to be like this. Set the example. Even if you want to do it with just one tiny data set inside of your own agency, right? Give it a try. and be present, go to workshops and meetups, write blog posts, just help set the tone for this public infrastructure so that it actually becomes public infrastructure and doesn't get eaten up by the same network effects and blitz scaling and this kind of stuff that eats most network effect technologies in the world. Because if the protocols for these things are open source and public good and linked with public institutions and serving the public interest, the future is a radically different place in terms of who gets to decide what our country's non-public information is used for, right? Then if this ends up being a big walled garden again, and our ability to leverage non-public information is gate kept through the license we have to buy or the platforms and enterprises that we have to bow down to. So yeah, that's the biggest thing. I know it's like a little bit vague, but it's just like more is better in all directions right now. There's a lot to do. But if you had to pick two things, education and pilots, I think are probably the two big ones.
Thank you for that. Let's go to one last question before we do our final poll and then wrap up. So we have a question: how secure are pets from potential cyber attacks?
Fantastic question. Got to be direct. Pets are a new type of security technology. So the theory, super robust, right? There's plenty of reason to believe that these things can be very robust technologies. In practice, there's hard work and infrastructure that has to be done to build great security infrastructure, just like with any other type of security infrastructure. So with that, there are great tools in the government, everything from FedRAMP to a robust ecosystem of white hat hackers and these types of things that need to solidify the new layer to the internet that we're only going to rely upon. So and then there's also for people doing early stage pilots, there are ways to run these types of systems in air-gapped environments. I know that might sound like a little bit of an oxymoron, but there are extra protections you can do in the early stages to give way above the threshold security guarantees for early adopters to help get these things going. It comes at the cost of speed, so you can't have the full automation that all pets provide if you're doing that, but it does help people get their remote access and remote research programs off the ground with very high security standards. So yeah, happy to chat. I know we're almost out of time. Happy to chat more about that. If anyone has questions, just shoot me a message.
Thanks, Andrew, very much. And thank you for all your questions. And now I think we are going to run our final poll. So if you can answer those questions, one question, actually.
I'm guessing, should I fill out the poll or not fill out the poll?
Sure, go for it.
Sounds good.
So thank you, Andrew, very much for your help, for your presentation today, and for joining our community. We're really excited about this topic and to hear more about it and to continue this conversation. And if you don't mind just including in the chat where people can find you if they have further questions or where they can reach OpenMined Slack, that would be awesome. And yeah, thank you to all of you for joining us today. I hope you found this useful and interesting and applicable to your work, and have a lovely afternoon. So take care, everyone.